So let's take a look at the Lewis structure for the carbonate ion. Whenever you're doing this, count the number of valence electrons we have to work with. I have one carbon, each one has 4 electrons, that's 4. 3 oxygens, each one has 6 valence electrons, that's 18, so I have 22 total. Now this has a charge, it has 2 negative. Which means now I have 2 extra electrons to play with. So plus 2, so I got 24 electrons. I'm going through the Lewis structure rules. I find a central atom. It's normally the one that's by itself, so it's going to be carbon. So what I like to do is put carbon in the middle, draw single atoms to the oxygens, and then put 6 electrons on each oxygen atom. So. Now, I like to count up how many electrons I've used up. So, I call this 1, 2, and 3. So, oxygen number 1, 2, and 3, each one has 6 electrons. So, 6, 12, 18. So, minus 18. Then also, I got 3 bonds, and each bond contains 2 electrons. So, that's going to be minus 6. So, when I do that, I have 24 electrons total. So, I've used up all my electrons. The only thing I can do now is, let's check to see if carbon has 8 electrons around it. Well, it has 1, 2, 3. It has 3 bonds, so it only has 6 electrons. What this means now, I got to start making double, triple bonds, etc. What I'm going to do is I'll take this pair of electrons from oxygen number 1. I'm going to move it here. So I'm going to make a double bond between that oxygen and carbon. So when I do that, notice that these electrons move down to here. Now this carbon has 8 electrons, so now it's satisfied. Couple of things. I could have just as easily taken that pair of electrons from carbon number 2 and carbon number 3. And so when I do that, before I close it up to do that, I could do that and I can do that. If I've done that, I end up with what they call resonance structure. So let me draw the 2 resonance structures here. Let me label this. 1, 2, and 3. So I have 3 possible resonance structures for this. Now, in reality, you're not going to have a double bond on one and 2 single bonds on the other 2. It's a combination of all 3 of them. So basically like 1 1/3 bonds throughout. The geometry, I look at carbon central atom. I have 1, 2, 3. I have 3 I have 3 bonding directions. So even though I have 4 bonds, I only have 3 directions along the central atom. That makes it a trigonal planar molecule. Planar means flat, so this is actually a very flat molecule. A couple things in terms of the polarity, since all 3 of these are going to be the same, this is actually going to be a nonpolar molecule. It all cancels out. So if you have a trigonal planar molecule in which all 3 of the terminal atoms are the same, it's going to be non-polar because they all cancel each other out.